Hello friends, welcome back to Learn with Ansh. My name is Ansh and in this video we are going to be discussing about identities of algebraic expressions. Now what are expressions? Expression can be defined as a combination of constants and variables connected by the signs of fundamental operations of addition, subtraction, multiplication and division. An identity is an equality which is true for all the variables. This is the definition of an identity. The definition of expression and identities, I will explain it further in the video. It's okay if you didn't understand it. Now, these are the four identities that we are going to be discussing. This is 1, 2, 3 and 4. Now, we will discuss these in sets and as you can see, this is set 1 and this is set 2. Alright. Starting off with set 1, we have a plus b whole square equals a square plus b square plus 2ab, and a minus b whole square is equal to a square plus b square minus 2ab. The reason why there's plus b square in a minus b whole square will be explained later on in the video while we're discussing on the proof of a minus b whole square. Firstly, a plus b whole square. A plus b whole square can be written as the product of a plus b and a plus b. That is basically what square means. Now, when we multiply these two expressions, now why expressions? Let's see. A plus b is an expression and we are multiplying it by an expression. So when we multiply these two expressions, we will get something like a square plus b square plus ab plus ab. I know this might be a little confusing. How did we get a square plus b square plus ab from a plus b to a plus b? The answer is by using distributive property. If you remember from the previous chapters, distributive property states that a plus b times c plus d is ac plus ad plus bc plus bd. Here, if we take instead of c and d again a and b, we will get a square plus ab plus b square plus ab. How? Let's see. AC. Here c we have written it as a, so we'll get a square. AD. Here d we have written it as b, so ab. So it's the same thing for bc, bd. We will get ab and b square. And now you know how we can multiply two expressions using distributive property. And now you know how we get a square plus ab plus b square plus ab from a plus b into a plus b. So, as I already said, a plus b times a plus b, which is a plus b whole square, is a square plus b square plus ab, which will become 2ab. Now, what if the signs are changed? What if it is a minus b whole square? Here, instead of b square which was earlier, we'll have to write minus b whole square. And you must have understood by now where the minus goes, because minus b whole square is actually b square, because minus into minus is plus. So if I say minus 5 whole square, I'm essentially saying 5 square, which is 25. Okay, this is where the minus sign goes, and this is why minus is only for 2ab. That is why we don't have minus for b. Second set, we have two identities again, a plus b into a minus b, which is a square minus b square, and x plus a into x plus b, which is x square plus a plus b times x plus ab. First, we look at the first one, and again we have to multiply a plus b and a minus b using distributive property, which we'll get a square minus b square minus ab plus ab, and these will cancel out, resulting in only a square minus b square. Here in x plus a into x plus b, you will get a plus b times x Because at first you will get ax plus bx, but then you'll take this x out common, so you'll get, when you get ax plus bx, we will take this x out common, so it will be x times, what do we have, a and x, but we have taken out x common, so what do we have left, a plus, same thing here, b, or a plus b into x, it's just the same thing. Now I'm not going to explain how we got this, because you can again distribute it and check it by yourself, you will get the same answer. Now let's have a look at what type of questions we can expect. So firstly, we have a direct question where we have been given the values of a and b, in this case 3x and 4y, and we have to find the square of their sum. So basically a plus b whole square. So a plus b whole square is equal to a square plus b square plus 2ab, and here putting the values of a and b, so a we have 3x, b we have 4y, putting the values we will get 3x whole square plus 4y whole square plus 2 into 3x into 4y. Now 3x whole square is 9x square, same thing here, 14y square, plus this will be 24xy. Now one common mistake which many of us tend to do is we only square the x. Over here we write this as 3x square, which is wrong. You're not supposed to just square the x, you are also supposed to square the 3, because what this a square means is 3x whole square. You're also supposed to square the 3, not only the x. Don't leave the 3 behind, it's going to feel lonely, alright? Same thing over here. It's not 4y square, it's 4y whole square, that is 16y square. The second type of question is pretty tricky. X plus 1 by x is given. You have to find x square plus 1 by x square, or x to the power 4 plus 1 by x to the power 4. So what you have to do basically is square on both sides, right? Remember, whenever you see something like this, you must square on both sides, and when you do so, you will get something like x square plus 1 by x square plus 2 into x into 1 by x, which is equal to 4 square, that is 16. Now over here, x and x can cancel, leaving us with x square plus 1 by x square plus 2, which is 16. Now when you see this question, what should go on in your mind is we need to somehow get x square plus 1 by x square. How do we somehow get x square plus 1 by x square? Do I know any identity? Yes, we have a plus b whole square, that is a square plus b square plus 2ab. If I write x as a and 1 by x as b, I will get a square plus b square, that is x square plus 1 by x square. But what do I do with the 2ab? Well, here we just saw it cancelled out, and now this 2 can be transposed over here, giving us x square plus 1 by x square is equal to 14. Whenever you see a math problem which you cannot solve, gather what all information you know, what all identities can be applied. The next type of question is finding the value of x. Now over here, you don't just jump in and find 45 square and 44 square. Alright, now I personally am lazy. When I see this kind of question, I don't just find 45 square and 44 square. I always, and you must always too, try and check for ways you can shorten this down. Okay? To be honest, finding 45 square and 44 square and subtracting them is not wrong, but it is also pretty long and time consuming, and there's a much efficient version of doing it, that is by using identities. That's why you must learn identities, so that you can solve things pretty easily. Here we just have 45 square and 44 square, which with some time and effort you can calculate, but sometimes you'll have things which you just can't do without identities. Okay, you need identities for doing it. So by using a square minus b square, of course we have loaded as a plus b into a minus b is a square minus b square, but we have enough common sense to figure out that it's the same other way around as well. A plus b into a minus b, that is 45 plus 44 into 45 minus 44. And to make things even more shorter, 45 minus 44 is 1, so 89x is basically 45 plus 44, which is 89x is equal to 89, which will give us x is equal to 1. And there we go. We did not calculate, we did not do any multiplication here. We did not do 45 into 45, we did not do 44 into 44, we did absolutely no multiplication. We solved it so easily that we can even solve it in our mind if we wanted to. The type 4 question, which is basically evaluating this, again here the teachers, the examiner don't want you to calculate 101 square. They are not testing you for calculating, they're not testing you for multiplication. That time is gone. That is in 3rd grade or 4th grade. This is 8th grade mathematics here. They won't test you for how well you can do 101 into 101. They will test you on how well you can figure out that 101 can be written as 100 plus 1, and when you square it, 100 plus 1 whole square, which is essentially a plus b whole square. This is what they are testing you for, not 101 into 101. Now sometimes if you don't know how to solve stuff, just write the identity. Just write whatever identity you feel will work there. Alright? These identities, you'll have to learn it. Okay? You can either, spend time repeating to yourself a plus b whole square is a square plus b square plus 2ab, or you can understand how they work, practice more problems, and it will just come to you like magic. Okay? It will just come to you. The identity will be in your head and you don't even know how. Now here when you do it, you will have 100 square plus 1 square plus 2ab, that is 2 into 100 into 1, which is 10,000 plus 1 plus 200, which you will get 10201, which is a palindrome apparently, because when you spell it backwards or normal fashion, you'll end up saying 10201. You can even verify it by doing a trusty multiplication. You'll get 101 00 101. This will be 10201. Okay, you can do this multiplication for verification purposes on your rough column, but this is not what 8th grade teachers expect you to do. This is not what 8th graders are supposed to be doing. This is what 8th graders are supposed to be doing, not this. The final type of question is pretty straightforward. Just multiply these two expressions and get the answer. Now, as long as they have not specified how you're supposed to do it, you can multiply it using distributive property or using the identity x plus a into x plus b, which is x square plus a plus b x plus ab. Since this video is all about identities, I will use the identity, but you can use distributive property, okay? As long as they're not specified what you have to use, you'll be fine. Now, when you do this, x square will just be x square plus a plus b is 2 plus 3, 2 plus 3 into x, which is 5x, plus ab, which is 2 into 3, that is 6, and there we have it, that's the answer. And I think with all these sums, I have proved to you that identities can make life so easy that a problem where you have to calculate squares of two double-digit numbers can just be done by just adding them. You just essentially adding them. And that would be it for today's video. Thank you so much for watching, and I'll see you in the next one.